Hello everyone, I'm going to introduce Saihu, the superimposed worst-case delay analysis interface for human-friendly usage. Before we introduce Saihu, we will first introduce a specific type of network called time-sensitive networks. Because some applications, like in the aerospace or automotive industry, they require critical timing guarantees. You may imagine a self-driving car has to make a decision to brake the car within milliseconds, and timing violation can cause catastrophic consequences. As a result, we have the time-sensitive networks that provide deterministic service guarantee on the delay. And particularly, it focuses on the worst-case delay analysis to address the timing issue instead of analyzing the average case as in the traditional approach. So, what is Saihu and why do we need it? Because we want to find the best delay bound for time-sensitive networks. But finding the exact worst-case delay bound is actually an NP-hard problem and generally not feasible. That being said, there are many analysis tools and methods that can give valid delay bounds. Each of these methods produce different results for the same network. Even though these bounds are all valid, when given a network, it's unclear that which method gives the best, smallest delay bound. There's no such one super tool that suits every situation. It always changes case by case. It's common to find a method obtaining a better bound for one network, but instead obtaining an inferior bound for another network. So it's best to try out as many tools as we can to find the best bound possible. What Saihu achieves is that it integrates three network analysis tools, namely XTFA, Disco DNC, and Panko. These tools altogether implement common analysis methods, including these following ones. Although these three tools have their own dedicated inputs, Saihu allows its user to define their network once and for all. And using that network definition, the user can then analyze the network with only one line of command to use all the methods and all the tools. And finally, Saihu produces formatted reports for the user to read the results immediately. Previously, without Saihu, when someone wants to analyze the network with different tools or methods, they need to do first, install and set up the tool, learn to use the tool by their documentation, implement a script accordingly, and then format and interpret the results by themselves. And say if someone wants to try out another tool, then he has to go through this process again. The inconvenience here is that you need to be familiar with different syntax of each tool, and sometimes it's even in a different programming language. Not only that, you need to define the same network multiple times, which is not only a tedious task but also error-prone during the process. Therefore, with Saihu, you need to only do first, define the network in a single file using one of the tool formats we provide, as you prefer. And then through this one-line execution, you can then read the results in formatted reports. So the first thing you need to do to use Saihu is to define the network of your interest. The physical network format is the first option you can choose to define your network. It allows you to represent a real network with physical devices, links, and flows, all by one XML file. For example, say we want to define this network. It has several devices connected by transmission links. The data flows labeled from F0 to F2 here. They go from data sources via switches with their input and output ports, and finally go to the sinks. With the example presented here, you can define the general network information, the stations and switches as the physical devices, transmission links, and the flows. The parameters of the flows and the devices are defined as their attributes inside these entries. The second option to define the network is the output port network format. As the queuing is on output ports only, we define this format to simplify the network representation to only writing output ports. For example, this network previously defined like this on the left can be defined like this simple form as an output port network on the right. To write down the network, we write a JSON file, which includes the general network information, output ports defined in a class of servers, and the flows with their parameters. You may ask, why do we need two formats? Although the physical network is closer to the real-world scenario, there are quite some details to specify, and some of them are even redundant for analysis. On the other hand, an output port network has all the necessary information and can be written in a more concise way. However, it may require extra translation from a real network because of its more abstract description. By providing both formats, Our user can choose to define their network according to their needs. No matter which format you may choose, it will not affect the delay bounds because Saihu will take care of it internally. After defining the network, say we save the file as demo.json, the user can simply execute this command that takes this demo.json and analyze it with all the tools. Saihu does an analysis and generates the report automatically. What's more, if you want to integrate Saihu into your own software project, Saihu provides its interface as a Python package that requires only this minimal amount of code to execute. After the execution, Saihu can generate two reports. We refer one as human-friendly report and the other one as machine-friendly report. As you can see, the human-friendly report is a markdown file that prints first the delay bound of the flows and the servers, the execution time of each tool and methods, the network topology, the flow paths, and link utilization of the network. It's designed to be easily read directly from the user. As for the machine-friendly report, it writes the same information but in a JSON file. Its purpose is to let the user parse them easily and do any further processing as they wish. As a result, we believe Saihu greatly simplifies the works of all network researchers. Feel free to check out our source code and documentation on our GitHub repo. Thank you for your attention.